Okay, so in this video what we're going to be looking at is how to simplify a rational expression. Remember, rational expressions are anything involving a fraction or an expression that is in the form of a fraction. That's everything you see here. We're going to be simplifying them, and we're also going to be stating the excluded values. So we're going to start with this first problem, and we have 12r to the 6th over 16r to the 5th. And the first thing we want to do is we want to look for the excluded values based on that denominator. We know we can't have 0 in the denominator, so we're going to say that 16r to the 5th cannot equal 0. And I wrote squared, but it's supposed to be 5th. Divide by 16 on both sides. We're actually just trying to solve for what r cannot equal. When we take a root of r, we're going to find that r cannot equal 0. So we've just stated the excluded values there. Before we go on, understand that the whole point of this is to identify what the variable cannot equal, because we cannot have 0 in any denominator of any fraction. So there are always going to be some values of a variable that we cannot have, because if you were to plug that value in, it would automatically make this an invalid denominator. All right, so then we're going to go on and start simplifying. That's the next step. We're going to find common factors between the numerator and denominator. The common factor is 4 and r to the 5th. And you can see that if I cancel out 4 and r to the 5th, what I'm left with is 3r over 4. Now keep in mind, what I did there was I broke 12 down and got 4 times 3. 16 is 4 times 4. And then, of course, r to the 6th is r times r to the 5th. And, of course, r to the 5th is just r to the 5th. So once those are canceled out, I'm left with 3r over 4. And that's my simplified answer. So that expression, when it's simplified, is 3r over 4, and the excluded values are where r cannot equal 0. Okay? So we're going to do the same process, same thing in question 2 here. We're going to look for where 50a cannot equal 0, because again, we cannot have 0 in the denominator. So when we solve for that, we're going to say that 50a cannot equal 0, which means that when we divide both sides by 50, that a itself cannot equal 0. Now we're going to look for common factors that we can cancel out between the numerator and denominator. So we have 80. 80 is the same thing as 10 times 8. 50 is the same thing as 10 times 5. And then a squared over a is basically a times a. And then over a. Notice that I broke it down such that we could easily see what the common factors are. We have 10 and we have a, so that's what we're going to cancel out. 10 and a, which leaves us with 8a in the numerator and 5 in the denominator. So 8a over 5 is our simplified expression. The excluded values are where a cannot equal 0. So that means that now we're ready to look at something a little bit more complex. So let's move on to this question where we have to actually factor a little bit more in order to figure out what our excluded values are going to be, because this is an entire quadratic. So we're going to say that x squared minus 8x plus 80 cannot equal 0. So if that entire expression cannot equal 0, I'm going to approach that the same way as if I were solving for the zeros. I'm going to factor that quadratic out. So the two factors I get are x minus 8 and x minus 10, and both of those are the factors now that cannot equal 0, because if either of these factors equal 0, then the whole denominator will equal 0. So that means that if x minus 8 cannot equal 0 and x minus 10 cannot equal 0, the two excluded values are going to be where x cannot equal 8 and x cannot equal 10. So those are the two values that we cannot have in the denominator, because if we do, this entire denominator would equal 0 and then would be an undefined value or a disallowed value for the denominator. Let's go on to simplifying that. Now the cool thing is that when I go to simplify here, I've already factored my denominator. I'm going to use the factors that I've got. So you'll see that for the numerator, x minus 10 is really already factored. It doesn't need to be factored anymore. I'm going to use my factors of x minus 8 and x minus 10 in the denominator. And you'll see that I have a common factor that can be canceled out. Keep in mind that if there is only one factor in the numerator, there's actually another invisible factor of 1 sitting here. So this is really 1 times x minus 10. So when I cancel out, I've got to keep in mind that there's actually a factor of 1 there. So x minus 10 will be canceled out. That leaves me with the expression that is 1 over x minus 8. That's my simplified rational expression. My excluded values are where x cannot equal 8 or 10. Now let's take a look at question 4. So in question 4, same idea, n squared minus 3n minus 18 cannot equal 0, so I'm going to say so. And then from that expression, I'm going to factor that. So I'm taking the factors of this and setting that up not equal to 0. The two factors are going to be n minus 6 and n plus 3. And that means that each of those factors cannot equal 0. So n minus 6 can't equal 0. Neither can n plus 3. And so when I get those solved out, that means that n cannot equal 6 and n cannot equal negative 3. Again, I've already factored out my denominator, so I don't need to do that again. All I need to do is keep those factors for this denominator and then worry about factoring the numerator in this next step when I'm simplifying. So I'm going to take a look at that numerator. First of all, I'm writing down, of course, my factored denominator, but I'm going to look at the numerator and say, all right, how do I factor it? It's got a GCF of 3n, and when I divide out 3n, I get n minus 6. I can see clearly that I have two factors that are in common there, cancel them out. That leaves me with 3n in the numerator and n plus 3 in the denominator. So that is my simplified rational expression. The excluded values are n cannot equal 6 and n cannot equal negative 3. Hopefully you can see that we are